Okay, good morning class. So before we go into our topic on calculus, differential calculus, we're just going to wrap up the class test 3 that you guys wrote the day before yesterday. In yesterday's lesson we went through our cycle test 2 of this year, which is 2022. Just right here, class test. Class test 3 term 2. Sorry about that. So this was the test you guys have written the day before yesterday. So we are told to sketch alongside are the graphs of g of x, which is equal to k to the x, where k is greater than 0, and y is equal to the inverse function of g. 2 and 36 is a point on g. The question says determine the value of k. So in pursuit of calculating the value of k, I'm going to substitute a point that lies on k, on g, which is 2 and 36, into the g of x graph. Okay, so that's the x and the y. G of x is the y, so 36 is equal to k squared. If I introduce square root, I must not forget plus minus, not so. However, k will be greater than 0. So k is equal to 6. Okay. So my equation now of g of x is going to be 6 to the x. Alright. The next question, they ask you to work out the equation of the inverse function. So what do we do for the inverse function? We interchange x and y, not so. So if g of x is equal to 6x, 6 to the x, then what do we do for the inverse function? We interchange x and y, so x is equal to 6 to the y. Then we must make y the subject of the formula, so we use logs. So y is equal to log x base 6. The base remains the base, and that is your inverse function. In 1.3, the question states, determine correct the two decimal places for which value or values of x is g of the inverse function of g. So this is the inverse function of g. Okay, where the inverse function of g is greater than 1 and 5 over 12. Now 1 is there, so 1 and 5 over 12 is approximately here. Okay, just over a bit. If I extend this graph will go through that way, okay, which is approximately. So what I need to know what the x values are, the corresponding x value. Not so. Remember that being 1 and 5 over 12. So the inverse function is greater than 0. So we are interested in that part of the graph. However, we first need to know what the x value is at that point. Not so. So what we do is, we say, okay, it's 1.3. We let g, the inverse function of g of x, equal 1 and 5 over 12. Why do I do that? So in order to calculate your x value at which that occurs. So the inverse function of g of x is log x base 6 is equal to 1 and 5 over 12. I make x the subject of the formula, so 6 to the exponent 1 and 5 over 12. So that x value works out to be 6 to the exponent 1. So I press shift. Do we get a mixed fraction? I press shift and that button. Okay, whoops, not that. 6 to the exponent shift that button. So it's 1 and 5 over 12. Gives us 12,66. Okay? That's 12,66. This is the x value here. So what do we say? X must be more than that. So therefore x has to be greater than 12,66. Okay. Take this off the yeah. Let's carry on. Then in the next question we are told that's number 2. The next question I want to know for which value of values of x is g of x times the inverse function less than or equal to 0. So what does that mean? Where g of x times the inverse function less than or equal to 0. When will something be less than or equal to 0? When it's negative. Not so. So for g of x times the inverse function to be less than or equal to 0 is when it's negative. When multiplying two numbers, when would it be negative? One is negative and one is positive. Or one is positive, the other one is negative. Okay. Negative and positive and positive. Okay. So, taking that into account, what do we know about g of x? G of x is always positive. Can you see that? So it's only, so that one doesn't feature because the g of x is never negative. Can you see that? So where is g, the inverse function? Negative. It's only negative from here onwards. Not so. From that value onwards. Okay. So in other words, it is from 0 till this value here. And what is that value? 1. So as you can see, it's a reflection in the line. Y is equal to x. That is 0 and 1 became 1 and 0. Not so. So it's from 0 till 1, where that is the case. Is that a continuous or a bracket solution? Continuous, is together. So x is greater than 0, but less than 1. Now you see, there's an equal sign here as well. Can it be equal at the 0? No. Why? In asymptote, the graph doesn't exist. Can it be equal to 1? Yes, because at 1 it's equal to 0. Okay. Let's go to the next question, 1.5. It says write down the domain of p of x equal to the inverse function of x minus 3. So something you must take note of at this point is that what is the domain of the inverse function? What is the domain of this function? What is the domain of that function? X is more than 0. Not so. So this part of the graph is. The domain is all possible x values. What effect does this negative 3 have on the graph? The graph moving 3 units to the right. It's moving 3 units to the right. Not so. So the asymptote, which is x is equal to 0, is also going to move 3 units to the right. Does it make sense? So, therefore x must be more than 3. Okay? When you get that question, always ask yourselves, what is happening to the original state? Or in this case, the inverse function of g. What's happening to that? What is the domain of that graph? And then you take the transformation into account. Okay?
So,
yes?
you said the asymptote also moves.
Yeah, the asymptote moves as the graph moves. Okay? For those of you who always battling with answering your 3 graph questions, okay, I'm busy with 3 graphs with the grade 11s. No? Here you go, watch those lessons online. Okay, it's a very detailed approach to 3 graphs. I know that's normally a sore point, and where you lose a lot of marks. Go watch the lessons one after the other. You don't have to do all the exercises. Just watch the lessons. If you don't understand something, you bring it to me, and I'll explain to you what you must understand. Okay. But at this point we must try and pick up everything that we can. Okay. The definite graph question in your upcoming exam is normally between 10 and 13 marks. Okay. 10, 15 marks sometimes. Okay, people in 2.2 and 2.1 setting, it says calculate, show all calculations, h of quarter, h of x is 16. So that would be 16 to the quarter plus, now we need the inverse function. The inverse function of h, interchange x and y. So y is equal to log x by 16. This is your inverse function of x. So we'll have 2 times the inverse function of h of 4. So that will be log x, which is 4, by 16 minus 4 to the 0, which is 1. Anything to the power 0 is 1. So 16 can be written as 2 to the 4 raised to the quarter plus 2 times. Now this can be written as log 4 over log 16 minus 1. Now a quarter times 4 is 1 plus 2 times. Now I can change this to 2 squared and that to 2 to the 4. Or I can just change the 16 and I say it's log 4 over log 4 squared. Now what's going to happen to the square? I can write this in front, not so minus 1. So that is simply 2. That cancels, leaves you a plus 1, minus 1. Give me an answer of 2. Okay? Any confusion there? Have you done logs? Yes. Have you guys practiced it? Okay, am I getting a learning class? Nice. Then it says show algebraically that h of x plus 2 is equal to 4h of x. So this is an identity left and right hand side story. So your left hand side is equal to, wherever we see an x, we replace it with x plus a half. So it's 16 raised to x plus a half. 16 can be written as 2 to the 4 raised to the x plus a half, which is 2. 4 times x is 4x. 4 times a half is 2. That's my left hand side. My right hand side is going to be 4 times h of x. And what's h of x? 16 to the x. Okay? So if 4 can be written as 2 squared times, 16 is 2 to the 4 raised to the x. So it's 2 squared times 2 to the 4x. When you're multiplying and bases are the same, we add the exponents. So it's 2 to the 4x plus 2. Can you see the same? Which is equal to the left hand side. Okay? The last question, no, not the last one. This question here. It says if f of x is equal to x cubed plus 3x squared minus 6x minus 8, show that x minus 2 is a factor of f of x. Now to show this a factor, we set that equal to 0, so x is equal to 2. So you want f of 2 equals 2 cubed plus 3 times 2 squared minus 6 times 2 minus 8, which gives you 8 plus 4, 12 minus 8, which is 0. Therefore, x minus 2 is a factor. Okay. Then I want to know, find the remainder when f of x is divided by x minus 1. So what do I do with that? Set this equal to 0. So x equal to 1. So f of 1 equals 1 cubed plus 3 by 1 squared minus 6 times 1 minus 8. So it's 1 plus 3 minus 6 minus 8, which is 4 minus 10. So the remainder is negative 10 when f of x is divided by x minus 1. The last question, solve the equation using factor theorem and division by inspection to solve for x if. So we had to test for x equal to 1, then minus 1, then 2, minus 2 and so on. Which one was the factor? X is equal to minus 2. Okay? So we'd have minus 2 cubed plus 6 times minus 2 squared plus 9 times minus 2 plus 2. And that gave me an answer of 0. Here we conclude. Therefore, x plus 2 is a factor of the given equation. So we got x plus 2 into. So x multiplied by what is x cubed? X squared. 2 multiplied by what is 2? 1. Alright, so that is going to give us 2x squared. So what must be added to 2x squared to give you 6x squared? 2x squared plus what is going to give you 6x squared? The answer is 4x squared. Not so? There goes plus 4x. 4x because I have 4x squared divided by x is 4x. So x is equal to minus 2 or x is equal to, into your quadratic formula, minus b plus minus the square root of b squared minus 4ac over 2a. And your x values worked out to be 1, 4 and 1. Negative 2 comma 6 7. 4. Sorry? Okay, let's just get there quickly. So 1 for 1. Negative 2 comma 6. Oh, 0, sorry, I already got 2 comma 7, is that correct? Okay, sorry man. And the other was negative 3 comma 73. Okay. So that's how you get 24 marks for this paper. Okay, wasn't that difficult? That's why most of you got full marks, okay? Nice. Start lying to ourselves. Start believing the lies within ourselves. Okay, people, that brings us to, not to polynomials, but calculus. Differential calculus. So at this point I've asked you to read through, and then as you know, time is catching up on us now. I ask you to read through and summarize a couple of pages, not so. So let's read what they are telling us here. This one we on page. Sorry, page 132, 142. And examples. We are reading through page 142. Differential calculus. So unit 1, we are told that when a function is undefined for a particular value of x, it is important to know how the function behaves near the value for x for which it is undefined. Okay? A function has a limit if it has almost identical values on either side of the undefined value. Okay? So that's very important to note, that a function has a limit. So that's the first note you're going to make. A function has a limit if it has almost the same identical values on either side of the undefined value. Okay. You can just highlight it in your book, and you can just write it down later. A function does not have a limit if it has different values on either side of the undefined value. That's basically the reverse in what they're telling you. Okay. Then we are told, consider the function sketched alongside. You see this graph, x squared minus 4 over 4x minus 8. If I substitute this, or if I put that into the graphing program, then you'll get a straight line out. Okay? But we know that this graph doesn't exist where x is equal to 2. Why? Because while the denominator here, 4x minus 8 can never be equal to 0. 4x can never be equal to 8, so x can never be equal to 2. And that is why it has what they call a removable discontinuity at that point. Can you see that, people? That graph is what they call a removable discontinuity. Okay? Why? Because everywhere else the graph is continuous. Not so. From one to the other. You can draw it with a straight line, without picking up the pen. Other than that point of 2. Can you see that, people? Why? Because it can never be equal to 2 because the sum is undefined at that point. You guys understand? So, just something to note at this point. I know they didn't highlight it to you at this point, but it's interesting to see if we take this fraction into account. If we factorize this, what do we get? F of x equals x squared minus 4 becomes x plus 2, x minus 2 over 4 as a common factor, x minus 2. So that cancels. So I'm left with a quarter x plus so on. And what do you notice? What type of graph is this? It's a straight line. There's our straight line graph. Only provided that x is not equal to 2, because the additional sum of f of x can't be equal to 2. Okay? It's interesting to note at this point. Okay, and it's an important concept to grasp for later calculation as well. So we are told f of 2 is undefined because 4x minus 8 is equal to 0 when x is equal to 2. I just did this calculation for you now. Not so. X tends to 2, or x arrow 2 means that x is almost 2. Okay, you will hear me say x tend to 2, or is going towards 2, or coming very, very close to 2. That is what that arrow indicates there. Okay, so x tends to 2 means that x is almost 2 but not exactly 2, and that the value chosen for x can approach 2 from both sides. F of x has a limit when x approaches 2 if the result is almost the same on both sides of 2. Alright, so you see here, what they did was they drew up a table. You see 1,9, 1,99, 1,999, 1,9999. They worked out values here. Can you see that, people? And then you got, for those of you who was a bit confused where that value is coming from, what they did was they said, okay, the function was answer squared, so it's answer squared minus 4 over 4 answer minus 8. Okay, so the last answer so we just put 1.9 as the first answer, and then we take it up, then we press equal to. So you see the 0.75. Not so. So if you go 1.999, there's now our last answer calculated. We put that into the function. You get 0.9975. Can you see that, people? If I put another 9, whoops. If I put 1.99999, you see, it's coming closer and closer to 2. Can you see that, people? As I'm coming closer and closer from the left hand side of 2. Okay? What do you notice about the graph? Whoops. I'm supposed to have substituted into the formula. What do you notice? The graph is becoming 1. Not so. But what will happen if I put 2 in? It will come to be undefined. Why? Because the sum, the denominator is 0 then. You guys understand? So what happens is, as the graph approaches 2 from the left, it's becoming closer and closer to 1. As I'm coming closer and closer to 2 from the right, what do you notice? The graph is coming closer and closer to 1. So what was the first note we said? We said that if the graph, the limit exists if and only if the graph coming from the left is almost exactly the same value as the graph coming from the right. Can you see that is 1 and this is 1? Can you see that, people? So the limit exists at that point. Okay. Right, so let's carry on. So we are told now that as x gets closer and closer to 2, from the negative side, the value is less than 2, the values of f of x gets closer to 1. From the positive side or from the right hand side, values greater than 2, the values of x is closer and closer to 1, which means to say it's coming from 1 from either side. Then we write here the limit. We say the limit exists if and only if the graph coming from the left and the right is the same value. Not so? So we're saying the limit, that's where this LIM coming. The limit as x approaches 2 of f of x is equal to 1. In spite of the fact that f of 2 is undefined. Okay. Then we are told it's important to note that you can simplify f of x equals x squared, right? We spoke about that there. And by getting this out here, if you have, you remember f of x equals x squared minus 4x over 4x minus 8, and we work that out to be a quarter x minus a half, no? What was it? Is the half? Yeah, the half. That's all. So, if you substitute 2 into this equation, this was a straight line equation, not so. Well, let's see what happens at f of 2. It will be a quarter times 2 plus a half. A quarter times 2 is a half. Not so. And half plus half is 1. So, interestingly enough, if I simplify the expression, and then substitute 2 in, you will see it comes exactly to the same value for which the limit on the original function actually approaches here, which is 1. Does that make sense? So not always are we going to draw the graph. What we're going to do is we're going to simplify and then substitute the x value or the limit value. You guys understand? Okay. Alright. So he said not all expressions has limits. For example, if we're looking at the limit of as x approaches 2 of 3 over x minus 2 does not exist, and the graph of y equals has a vertical asymptote. So if I draw this graph quickly, I'll show you here. Remember, what is your horizontal asymptote on this graph? Is y is equal to 0 here, not so, which is your x-axis. You've got a vertical axis of what? X is equal to 2. So x is equal to 2 there. Alright, so this is positive. So the graph is now in quadrant 1, quadrant 3. So what is the definition for a limit? A limit will exist if the graph coming from the left is almost the same as the graph coming from the right. So if you're looking at the graph coming to 2 from the left, what do you notice? The graph is going to negative infinity. Can you see that? What happens if the graph coming from the right? Positive infinity. So is the value coming from the left and the right the same? No. So what does that mean? The limit does not exist. Does it make sense? Okay. Now if you're looking at, but I just told you now that we're not going to draw the graph every time. What we're going to do is we're going to simplify, not so, and then substitute the limit value in, the x value. So if you're looking at the limit as x approaches 2 of 3 over x minus 2. Now can I simplify that there? Can I simplify that? No. So we just say therefore the limit does not exist. Okay. So we carry on reading here. We are told that there is a vertical asymptote given by x equal to 2. Then we are told that the limit as x approaches 3 of 3 over x minus 2 is equal to 5. Now, if we're looking at, coming back to that graph there, you see for the next question they are asking the same graph, but where's the limit as x approaches 3? But if we look at where 3 lies on this graph, remember that's 2, so 3 is approximately here, so 3 would lie there. Is this graph continuous at 3? Does the graph exist at 3? Yes. So to calculate the limit value there, that's LIM, the limit as h approaches 3 now, of 3 over x minus 2 will simply be 3 over 3 minus 2. And 3 minus 2 is 1, so the answer is 3. So that limit value as x approaches 3 from the left and the right would approach 3 on the x. You guys understand? And likewise for minus 3, you'll get an answer of x is minus 3. No, not x minus 3. It will be 5 over... Now you see here again. Okay, I thought it's going to be the same. It's actually a different equation. But what you notice here, again the limit won't exist. Can you see why? Because I can't simplify that. Okay. However, here again, for the fourth bullet, the limit as x approaches negative 4, of 5 over x plus 3, to substitute minus 4 in there, and then you get minus 5. So does this limit exist? Yes. At minus 4. Where does the limit does not exist is at x equal to minus 3. Okay. So again, that's your vertical asymptote that comes into play here. Okay, we are told to remember division by 0 is undefined. 4 divided by 0 is undefined. And then x minus 2 over x plus 3 is undefined if x is equal to minus 3. The limit of the function f of x is the value it approaches as x gets closer to the particular value there. Keyword identical, exactly the same. Asymptotes, a straight line that the graphs get very close to but never touches. There are many graphs that we draw asymptotes, the logs, the exponential, hyperbola graphs have your asymptotes in. No? Which other graph has an asymptote which I haven't mentioned? Okay, all at once, just one at a time. Your tree graph. No? It also has a vertical asymptote there. Remember that a over x minus p plus q is a hyperbola, a vertical asymptote of p and a horizontal asymptote at q. We often need to factorize the fraction before you can cancel. So x squared minus 2x minus 3 over x squared minus 9 cannot be simplified in this form. Okay, what do we need to do first? We need to factorize. Not some people, and I've seen this over the years as well, where people say, okay, x squared go to x squared what? X squared go to... You can't do that. Why? Because there's more than one term in the numerator and more than one term in the denominator. So what needs to be done first is I need to factorize the numerator, and it factorizes into that there, factorize the denominator, that cancels, leaves you with x plus 1 over x plus 3. Okay. Can we carry on? So now consider the function g of x equal to negative 4 over x minus 1. G of 1 is undefined because the denominator is equal to 0. Not so. Can this be simplified, people? No. So does this limit exist? No. Okay. So g of 1 is undefined because x minus 1 is equal to 0, so x is equal to 1. That means x tends to 1. That means that x is almost 1, but not 1 quite. Or not quite 1. G of x has a limit when x approaches 1 only if the value of f of x is almost identical for x values which is closer to 1 but not equal to 1. But is it identical? No. So the limit does not exist. And here's a table. As you can see here, what they did was they took values from the left hand side. Okay, they took values from the left hand side approaching 1 and took values from the right hand side approaching 1. So what you notice as it's approaching 1 from the left hand side, the number is getting bigger and bigger and bigger, which means to say it's tending to infinity. It was coming from the left hand side, from the right hand side, sorry. What do you notice? The number is getting smaller and smaller and smaller. So since that value on this side is not equal to or identical to the value on the right hand side, the other side, the limit does not Okay. As x gets closer and closer to 1 from the negative side, the value less than 1, the value of f of x gets bigger and bigger. From the positive side, the value gets smaller. The result shows that g does not have a limit when x equal to 1. So, the limit as x tends to 1 of negative 4 over x minus 1 does not exist. Okay. Here we go. Exercise 1. Now, we don't have time to draw a table and all of these things. Okay, we don't have the luxury of that. No? So for those of you who have the time, please, if you really want to draw a table, by all means, but not on my time, no? Not under my watch. We've got better things to do than that. Okay? But exactly what I've explained to you in the explanation or the introduction to this is exactly what they want you to do. Okay? But as I said, we don't have that time. So this is exercise 1 and this is on page sorry? 140. Wow, nice man. You're clear, you're becoming clear now. No? I like it. Alright. Exercise 1 on page 143. So, normally the question comes in determine the limit or simplify. So what I'm going to do is, I'm going to do this column with you now, and then that column is going to be homework. Okay? Is that okay? The first column I'm going to do now, second column is going to be for homework. Okay? Right, let's go. A. We are given the limit as x approaches 0 of x squared minus 2x over x. Now, if I substitute that x value straight, what do you notice? The denominator will be 0. It will be undefined. So what do I have to do first? Factorize. So factorize quickly. Alright, so that would simply be the limit as x approaches 0 of x into x minus 2 over x. So what happens? X is cancelled. So now you've got the limit as x approaches 0 of x minus 2. Not so. So wherever I see a x, I put a 0. And I drop this limit now. Once you do that application, once you use that limit, we drop it. With that value for x, we drop it. There's going to be 0 minus 2, which is negative. You all agree with that? You all understand? Let's do C. Look at C. So here we have the limit as x approaches 2 of x squared plus 2x minus 8 over x minus 2. Can I substitute 2 straight? Why? The denominator will be 0. So I must factorize the numerator first. So do that quickly. Right. So this here, we can't factorize straight. So you got the limit as x approaches 2 of x minus 2, x plus 4 over x minus 2. Not so. Drop that. So that would simply give us the limit as x approaches 2 of x plus 4. So that will give you an answer of 6. You all agree with that? Right, let's try and complete quickly. E. So we got the limit, yes? It's a negative 2.
It's x minus 4.
X minus 4. So you say there must be a minus 4 here. Is that right? Or do you factorize the wrong number? Remember 1 plus 1 minus, the bigger one must be plus. Not so? Right, no problem. Let's look at E. So you got the limit as s approaches negative 2 of 3 over s plus 2. Right, can I simplify that? No. Not so? So therefore the limit does not exist. E, F, G. So you got the limit as s approaches 3 of 2s squared minus 3s minus 5 over 2s squared minus 5s. So again we can't substitute it into here. Can we substitute it into the denominator? Without giving us an answer of 0? Let's check. It's going to be 2 times 3 squared minus 3 times 3 minus 5, and this is all over 2 times 3 squared minus 5 times 3, 4 over 3. So did I need to simplify this here? No, because why? The limit actually exists at 3. Can you see that, people? But if you had simplified and substituted 3 in afterwards, you still get 4 over 3. Make sense? GI. Of course, I don't think that's going to work. We'd have to factorize the numerator and denominator. Cancel from there and then substitute to 3. Alright? Add an I to your homework and I'll do it tomorrow as well. People, for homework, we are way behind. No? So I want you guys to read. You should have read at this point page 144, 145, 146, and then we're going to go straight into first principles tomorrow. So please read through those pages for tomorrow's lesson. Enjoy the rest of your day. Good morning, class. Oh, it's break now. Where could have gone another extra few minutes? But you guys wouldn't be happy, eh?